Hello student, welcome to my new channel MEP Tutorials. In this channel we will learn how to design the MEP services, that is mechanical, electrical and plumbing. So let us start with the HVAC. In this HVAC topic we will learn how to design the HVAC system by using the formulas and calculations. So let us start the new topic, that is HVAC formulas and calculation. Before starting the topic, please subscribe my channel, that is MEP Tutorial, and click the bell icon to get the notification. So let us start HVAC formulas and calculations. The first point we will learn, that is thumb rule. The second is basic conversions. Basic conversions are also important to design the HVAC system. Third one is the energy conversions. Energy conversions are very much important to design the HVAC system. The fourth one is the formulas. Formulas is also available to design the HVAC system. So let us start the HVAC formulas and calculations as well as the conversions. The first is thumb rules. There is the thumb rule for tonnage calculation. 1 TR is equal to 125 to 150 square feet. It means if you have a 150 square feet area, then your requirement of air conditioner is 1 TR approximately. CFM calculation. 1 TR is equal to 350 to 400 CFM. It means if you have 1 TR air conditioner, then airflow rate is between 350 to 400 CFM. That is, 1 TR cooling is only achieved when the static pressure and the RPM, that is revolution per minute, of a certain air conditioner fan provide that much CFM, that is cubic feet per minute airflow. Generally, static ductable AC unit requires 400 CFM airflow to achieve 1 TR cooling, whereas low static ductable AC unit required 350 CFM approximately. Airflow calculation by air changing rates. There is the formula to calculate the CFM airflow. Let us start. So CFM is equal to air changes per hour multiplied by room volume in a cubic feet divided by 60. Here 60 is the conversion of hour to minute. CMH, that is cubic meter per hour. CMH is equal to air changes per hour multiplied by room volume in a cubic meter. Basic conversions. Basic conversions is like this. Let's come to the length. 1 meter is equal to 1000 mm. 1 inch is equal to 25 mm. 1 meter is equal to 3.28 feet. 1 feet is equal to 12 inch. 1 meter is equal to 40 inch. 1 feet is equal to 300 millimeters. 1 feet is equal to 0.3 meter. Again the basic conversions is 1 FPM, that is feet per minute, is equal to 0.005 meter per second. 1 meter per second is equal to 196 feet per minute. 1 CFM is equal to 1.72 CMH, that is cubic meter per hour. 1 cubic meter per hour is equal to 0.58 cubic feet per minute. 1 CFM is equal to 0.47 liter per second. 1 TR is equal to 2.66 GPM, gallon per minute, and now this is applicable only in water cooled chiller. 1 liter per second is equal to 0.001 cubic meter per second. Now let us come to the energy conversions. In the energy conversions, 1 TR is equal to 12,000 British thermal unit, that is BTU. B. 1 TR is equal to 3024 kilocalorie per hour. These are the energy conversions unit. C. 1 TR is equal to 3.52 kilowatt. D. 1 TR is equal to 12,660 kilojoule per hour. E. 1 kilowatt is equal to 3412 BTU British thermal unit. F. 1 HP, that is horsepower, is equal to 0.7275 kilowatt. G. 1 kilocalorie per hour is equal to 3.97 BTU per hour. H. 1 kilojoule is equal to 0.24 kilocalorie per hour. I. 1 kilojoule per hour is equal to 0.95 BTU per hour. So let us come to the formula. The fourth number is the formula. This formula is required for the ducting, air distribution products, etc. So let us start with the formulas. How to calculate the duct area? So this is the very simple formula required to calculate the duct area. Duct area is equal to CFM divided by velocity. That is, standard velocity is 1200 to 1500 fpm for supply air duct. Duct size. How to calculate the duct size? The duct size is equal to CFM divided by velocity into 144. Now what is this 144? This 144 is the square inch. Now by calculating all this, divide it by the height of the duct. So you will get the width into height. So finally we want the width, and now we are getting the width into height. Now how to calculate the supply air collar size? So this is the formula. Supply air collar size is equal to CFM divided by 350. The 350 is the standard velocity to required supply air collar size. So then we will find the area. So calculate the multiply 144 by that area, then the answer will come, and then divide it by the height, so the width will come, so that will be the supply air collar size, the collar width as well as the collar height. So width into height, that is the supply air collar size. Now how to calculate the return air grill size? So this is the formula. The return air grill size is equal to CFM multiply by 1.3. Now what is this 1.3? So we are taking the 30% of the entire area of the return air grill. So CFM multiply by 1.3 divided by 350, that is velocity. So ultimately the area will come, and then calculate this area by 144, that is square inch, and divide the answer by the height. So you will get the return air grill size. Supply air diffuser size. How to calculate the supply air diffuser size? Very simple. Supply air diffuser size is equal to CFM divided by 450, the standard velocity. So the area will come. Now calculate by multiply by 144, the answer will come, and take the square root of that answer, then you will get the width multiplied by height. So here for the supply air diffuser, you will get the both side width only, not the height. So we can find out easily the supply air diffuser size. Supply air plenum. Supply air plenum requires to connect the two duct or connect the flexible duct in a HVAC ducting design. So how to calculate the supply air plenum? Supply air plenum is equal to CFM divided by 500, that is the standard velocity required to calculate the supply air plenum size. So CFM divided by 500, that is the standard velocity, then multiply the answer by 144, and then divide the answer by height of the plenum. So you will get height, width, and the height of the length of the plenum. Thank you for watching my channel.